So in last lecture we have started with gravitation, and in this lecture we are going to study geostationary orbit and the geostationary satellites. The satellite which appears stationary from the earth, these satellites are called as a geostationary satellites. For example, suppose this is earth and the satellite which appears stationary from the earth surface. Geo means earth and stationary means steady. The satellite which appears steady from the earth surface, such a type of a satellite is called as a geostationary satellite. Suppose this is a satellite at a particular distance from the earth surface. Now when this satellite orbits around the earth, so the distance traveled by this satellite will be the perimeter of this orbit. Okay, so this will be the distances traveled by this satellite. So 2 pi r is the distances traveled by this satellite in one revolution or in time period t. Now here we can see that this time period t and this r has a direct proportion. Okay, now if this r increases, r is the radius of this orbit. If this r increases, the time period will increase. If this r decreases, this time period will also decrease. Now geostationary satellite means this satellite should be steady with respect to the earth surface. Okay, so whenever any observer is standing on the earth surface, he could see that, or he should see that satellite each and every time of the day. So such a type of a satellite is called as a geostationary satellite, because this satellite is used for different purposes, like it can be used for the communication, for research purposes, different purposes which we have seen in a previous lecture. So this satellite is continuously sending the data to the earth surface. Okay, and there will be a receiver over here, and that to that receiver, I will draw that receiver like this. So to that receiver, so this satellite should be stationary. Then and then only it will collect the data from the satellite which is sending. And then only this receiver will collect the data from the satellite. Therefore, it should be stationary with respect to the earth surface. Now we know that this earth is revolving around itself with a time period t is equal to 24 hours. Okay, now we know that this earth revolves around itself. Okay, the earth has a spinning motion and the time period of the spinning motion is 24 hours. Actually it is 25 hours and some 56 minutes and some 7 seconds, etc. So for more accuracy, so we nearly take it as a 24-hour for simplicity. Now as this satellite should be stationary, so it must also have the time period t is equal to 24 hours. Now this is the earth surface. Now if there is any satellite revolving around the earth at a height of nearly 2000 kilometer from the earth surface, so such a type of orbits are called as a lower earth orbit. The orbits of the satellites in the range from 2000 to 35,000 kilometers, then these are called as a medium earth orbits. Above this 35,000 kilometers, so these are called as a higher earth orbits. The geostationary orbit is one which is revolving at this 35,000 kilometer. Actually this is also 35,786 kilometers exactly. Okay, so what happens at this certain particular height? So at this height, the time period of the period of the revolution of the satellite becomes exactly equal to the 24 hours. Okay, that's why when the earth is rotating, the satellite will rotate with the same speed or with the same time period of the revolution. So at that particular height, now suppose this is the height at the 35,786 kilometers. So when this satellite is at a height of this 75,000 kilometers, then at that time the time period of the revolution of this satellite will be exactly equal to the period of revolution of the earth. Therefore, so whenever this earth surface is moving or this receiver is moving, along with that this satellite is also moving with the same time period. Okay, therefore if you are standing near this receiver, you can see that this geostationary satellite is always steady with respect to the earth's surface. So this is called as a geostationary satellite. Now these geostationary satellites are generally in a, or not generally, they are exactly on the equator of the earth. We know that the imaginary line passing through the center of the earth. Okay, if these are the pole. Okay, now this is a north pole and this is a south pole. Okay, so we can call this as the equator of the earth. So this is the imaginary line which is passing through the center of the earth. So this is called as the equator. The geostationary satellites are always on the equatorial plane, in a equatorial plane. So these are called as the geostationary satellites. There are some certain satellites which are called as the geosynchronous satellites. I'll write it here. So what these geosynchronous satellites are there? So geosynchronous satellites also have the time period of the 24 hours. They are also revolving at the distance of 35,786 kilometer. Okay, so the time period of the revolution and the height of the orbit is exactly same as that of geostationary orbit, but this is not necessary on an equatorial plane, so it might be inclined like this. Okay, so the geosynchronous satellites are not on an equatorial plane of the earth, but they are somewhat tilted. Okay, and the receivers of those geosynchronous satellites could also move from few degrees in a south and north also to exactly capture the geosynchronous satellite. So the geosynchronous satellite is not stationary from the earth's surface, so it is seen to move from a little bit distance from in a north side and also in a south side. So the receivers can also move in a little bit angle of the north side and the south side. So these are called as a geosynchronous satellites. What type is there which is called as a polar satellites? Polar satellites are moving from the poles. Okay, so they are moving in the vertical plane, so they are moving from the poles. The rotation of the earth, and this is the rotation of the polar satellite. So what happens, so each and every area, so that is covered by that polar satellite, and these polar satellites are present in a lower earth region or the lower earth orbit. As these polar satellites are present in a lower earth orbits, mean they revolve at a distances lower than the 2000 kilometers. Then they revolve with a very high speed, or they revolve with a high time period, and the satellite which is nearly at say 700 kilometers from the earth surface, so that may take the 40 revolutions per day.